All right, I think we're on. Good morning. Good morning. All right. So today we are continuing the design of the Thorn Buckingham TBRD01 trophy truck. And so that's kind of where we're at here. We've got this is the point we got to yesterday. We've got a essentially a brand new unequal length A-arm front end. This design, what's kind of special about this one is unlike the Mayday MDRD01 trophy truck, which uses a little link pin at the top, which is prone to breaking in a crash or a hard hit. The TB RD01 basically integrates this entire assembly into one printed part, which looks like this. When it's printed, it's completely flat, and then it gets folded up into this. Let's for now, let's just and so that's kind of what it looks like folded up. And so, yeah, I'm pretty happy with kind of where we're at. I haven't done a front end like this that gets printed flat and then folded up. But essentially, there's a pivot joint there and there that fold, and so. So yeah, so yesterday we designed that flexible assembly. We also designed this component here in the center, the tapered chassis bit. And then kind of after we wrapped up yesterday, I added a couple more little things. It's a little hard to see in there, but the pocket for the ball end link to snap into for that little white pivot there. And then I also added, I don't know if you can see this here, but a little bit of a flare kind of right out at the end. And that is designed to sort of snap through the bearing and then retain it really solidly. So it makes it a little bit more challenging to put on, but it also makes it much more resistant to coming off. So it's retained much more solidly. And I'm pretty happy with those dimensions. So you can kind of see kind of right there, that's the retention. And it's got this chamfer because when it's in the printed state, it's printing up like this. And so the 45-degree chamfer there just essentially means that you don't need supports. Because again, those are the rules for the ClickRigs design. Everything needs to print without supports, and all of the major components need to be either made out of TPU 95A or a rigid plastic like Polymaker PLA Pro, which is what we use at the print farm for manufacturing of all these, and so obviously that's what I prototype in as well. So let's figure out what we want to do next. So I've got this, I think the shapes are pretty well dialed. Everything's kind of cleaned up and rounded. We've kind of got some nice smooth transitions in there. I went in and added a little bridge. I think what I would like to do though is add a stiffening plate. So out of the rigid material, a stiffening plate that pops on kind of to the top face of this lower arm, because basically the loads is this wheel. As this wheel travels up, the butterfly spring right here with this little, it's getting close, with this little ball link is that white link in there. That's what transmits the spring force and maintains the ride height and resists bump. And so as that goes up, you've got kind of a force that's pushing kind of on it right there, and then acting through this connection here at this pivot. And what that tends to do is bend or cause this to want to arc. So I think if we stiffen that up, we can kind of get essentially better control over that arm. I don't think we need one on the top, but we'll do that on the bottom. I also think I want to move the spring pivot inboard just a little bit, because you can kind of see how angled out that is. Kind of, but we're not going to get that much droop. We're probably going to fall right about there and then up. And so I think I'd like to move that inboard just a little bit and add a stiffening plate. And then when we add a stiffening plate, we're also probably going to have to give it a little bit more clearance on that tapered chassis, kind of right inside of there, or it'll hit. So we might have to bring this tapered chassis up and around instead of a straight line. So let's do the spring plate first, and then we'll figure out how much clearance we're going to need on the chassis. So that spring plate is basically going here. We're going to start, let's start by moving these. Actually, we're going to need a little bit more meat here. So that's probably going to be this sketch. Let's turn on our grid layout just so we can get a sense of where everything lands. It's probably this relation. Yep. I'm just going to give that a dimension, because it doesn't really need to be linked to the grid for any particular reason. Let's just call that 17. Turn the grid off. So that should all be good, because I'm pretty sure this first transform brought it into this edge, and then we just bumped it over with the second transform. So that moved correspondingly inboard. Just kind of want to check it out in here. I'm just kind of curious. Let's go crazy. I think that's too much, but I do kind of like 20. I also think too that once we add a stiffening plate to the top, we can probably make this a little bit less deep, which should give us a little bit more ground clearance on the bottom. But let's start with the plate. I'm gonna go over here and just kind of get a recollection of, so that's 2 millimeters. Let's hide this really quick. Those are 2. Okay. So let's just do a sketch. So what I'm doing is I'm just essentially extend those. Just kind of cleaning that up. Maybe kind of, let's fillet some of these. not 12, 1. It's pretty good. And so now we're going to need a little pocket around this thing. So what's the best way to do this? We'll do a couple center lines. Then we'll do a rectangle. Then we'll use our left to right trick. And that means if you basically box select right to left, it'll select everything it touches. If you go left to right, it will only select things that you completely enclose. So again, we go left to right, we get nothing because nothing was completely enclosed. But we go right to left, we get both those lines. And we're just going to add a symmetric relation, and then I'm going to do the same thing here, add a symmetric. And so now we can draw the rectangle however we want, but it's always going to be essentially centered on our little pocket there. It's going to do some fillets here as well, not that big. See that one as well. And then let's just add kind of an offset here. We don't need much. Let's go 0.5 millimeter. I'll do one here as well. That's probably good. And this whole thing, when we extrude it, is going to get drafted, so there'll be a little more clearance as well. So let's start there. So let's extrude that. It's going to be a new part. We'll match 2 millimeters, and then let's draft this 15 maybe? Not that way. Just kind of playing around with values. Maybe 20 degrees. That's not too bad. I do kind of think 2 millimeters might. I mean, we use 2 millimeters on the trailing arm, which is much longer than that, so we probably don't need. What if we went 1? We'll try 1 and see if that's enough. Cool. So I think that's pretty good. So now what we need to do is we need to add some snap studs to it. So let's hide this part for now. Let's do a sketch on the bottom. And let's just add some reference lines. Let's give it a parallel relation. How's that B? It's always nice to try to, so if you kind of notice the little tooltip in parentheses, it has the lowercase b. That's just telling you that there's a hotkey or a keyboard shortcut for it. And so it's always, I try to learn them, so whenever I see them. Parallel is a relation I don't use a ton, and so I didn't know the keyboard shortcut, but whenever you can, it's nice to learn it. So let's see. So what I really want is this thing to be centered, and I chose that center line, and it makes sense why that doesn't work. So let's delete that one. So now we can kind of, I do want this to be coincident though, which basically means I've made this point at the end of this line coincident to this line. And so we have two relations going on here. This line and this line are parallel, and this point and this line are coincident. And so I can drag it around, and those things, it's never going to not be parallel, and it's never not going to touch there. And then same, this point and this line are coincident. And so that's, if you don't know what parametric CAD is, it's kind of that. It allows you to define everything with dimensions, but also with relations to the geometry itself. And so that's why I say that like building a model in parametric CAD is kind of like building a machine that results in a shape, because those shapes can be driven by parameters if you set everything up correctly. So what I want is for this line to be in the center between this line and this line. So how do we do that? There are a couple ways, but I'm just gonna do another construction line. I'm gonna go from here to there, and then what we're gonna do is we'll select these two lines, and then we want them to be perpendicular. And so, well, that one's complicated. It's got a shift in it. And so now this line and this line will always be 90 degrees. And so actually let's just we could add a point in here in the center. I'm just going to delete because we don't need that coming out. And so now what we're going to do, see, because we deleted that relation, so now we can drag it around. Still stays parallel. But now what we can do is snap it to this. Oh, we didn't hit the snap. Oh, there it goes. Snap it to the center line of this. So now this line basically tells us where the center is between these two, which we could do with dimensions. But by doing it this way, if the dimension between here and here ever changes, this will automatically adjust because it's based on a relationship between the geometry and not a specific number. So it's kind of, you could say this, where this line is not hard coded in to the system, because you know, if I got rid of that and I said, okay, this thing is 5.5 millimeters across, so I can add a dimension between the two that's like 5.5 divided by 2. Now that's another thing too, and the dimensions you can enter equations, which is kind of handy, and it gives you that little equation symbol there. And so that puts the line in the same place, but if I ever change this, like if I go back into the other sketch and I change this dimension to be different, this is going to stay the same, which means that this line will end up being like closer to this line if this gets wider, and it'll be like farther away from this line if it gets narrower, and that's not what we want. So we're trying to, as we go, we're trying to build the model so that it can adapt to whatever changes we might want to make in the future. And so that's why I'm not going to do that. I try to do everything with relationship references, and then have as few dimensions as possible, and make those dimensions that drive everything the dimensions that are either critical to the application or that I think will change. Like maybe I don't know what the dimension is yet that this thing has to fit, but I can go in and design the part anyway, and then once I have the dimension, just plug it in. And if I've built the model correctly in a good, clean, parametric way, that whole model will update in the correct manner without too many problems. You know, and it doesn't always end up perfect like that, but you do what you can. And so, and then notice those lines turn black because that is now fully constrained or fully defined. And again, the way this works, I made a line, construction line, that is always going to be coincident with this line and this point with this line. And so as these lines change, this line will adapt to match it. And then this line, I made it come in, I made it parallel to here, and then I brought it in to the center point of this line. And so that means no matter what happens to this dimension, this line will always be centered between the two and parallel to them. And so that kind of gives us now a starting point to do some snap circles. How many do we need? I don't know, but let's $3.5. But basically, the more we have, the more tied it's going to be to the TPU, the flexible component of the A-arm, and so the stiffer it will be. But you know, you don't want to do too many. So let's dimension this. Well, we're going to say that was a 3.5. So see, that's pretty big. And then we could go and add a dimension for all of these circles, but again, we can just kind of, we're going to do a relation. So we're going to select all these and we're going to say they're equal. And so now, if I change this one dimension, they're all going to change. So let's see, that's probably good. I'm just going to set that to tangent. So now you see that one is fully defined. And right now I'm just kind of moving them around and getting a kind of an eyeball sense. I could do a dimension there, but I think we only really need 2 here. So I'm going to, so that edge is tangent to this line. So now we've got a couple of studs there. I think we're going to want another one here. This might need a, we'll just call that. It's probably good. So the question is, can we get away with just one in the middle? Does that look right? I think that looks right. And I'll probably do one in here just to kind of stiffen it up where the load comes through around the ball end link, because that feeds everything into the spring. So what I would really like to do is define this with a relation. So it's always in between these two. Now, I don't actually know of I mean, if these were defined not according to this, what happens if we trim this line? Can we just get rid of that one? Oh, look at that. So, interesting. Can we get... Basically, I just don't like laying lines over the top of other lines because it kind of makes it difficult to see what's going on. But our relation's held up. I mean, can we just... So I'm hitting M, which is trim. So basically we'll just kind of trim out. Okay, cool. So really we only need this line, but even though the line doesn't fully extend, you know, this, you can see if I highlight the relation, is this dot and this line are still related to one another, even though the line doesn't visually extend all the way there. It does in concept. But that opens the door, so now we can do another construction line between the center points of these two circles, which is now fully defined. And this might over-define it, but what we can do is we can now snap this to the center of that line, and that everything's fully defined. And so now, again, if anything here changes in this setup, this will always be centered in between these two things, which is kind of cool. And so this whole sketch only uses two absolute or hard-coded dimensions, and that's this diameter right here, and then this offset distance. And so, like, if we change this, let's say we made that 5 millimeters. Notice how this circle is still centered, even though this one and this one got closer together. This one is still centered. We don't want that there. Let's go back to 1. And we could probably come up with a way to define that as well, but I think geometrically speaking, just a fixed offset is fine. You kind of always want the same offset, even if this whole arm becomes longer or whatever. And so now I kind of want one more circle right in here. We're going to make that equal. I almost feel like I want this. So notice how this snaps. So whenever you get a snap like that, it's going to automatically add one of the relations. And so this is now perpendicular to this line. Let's just make that on the end. So now we can't move it. We're only unconstrained in this dimension. And I almost wonder if we just keep kind of our fixed offset concept. It might be too much, but I also don't, it looks nice being perpendicular there, but from a functional standpoint, that's probably the best. And so now let's just put a center line there. And we're going to mirror that. She's barking at something. There might be somebody coming into the door. We got somebody coming to work on the yard. And I'm going to go check it out. I'll be right back. Hold on. All right, sorry for that. We are back. Okay, let's go back to the browser. Okay, so we are adding these kind of snap dot holes, and I've already forgotten. 2 millimeters. So I've used this. This has worked pretty well, so I'm just gonna kind of keep reusing those rough dimensions. I forget what. No, that's not what I wanted to do. Just gonna double check. Okay, so these are 3, not 3.5. That actually helps us. And I go up to, oh, I added the draft separately. 3 degree draft. Okay. So these are actually 3. That's a little nicer. And then we're going to extrude these. We're going to go up to, I think we can just add, might as well add the draft in here. 3 degrees. Just like that. And .6 millimeter fillet. So that is a lot of snap, but that means this thing should be nice and secured. Oh, I'm like, why is that in the folded up state? I turned on the wrong part. Let's rename that. Let's just rename this while we're at it. I kind of like verbose names sometimes, so lower A-arm stiffening plate. So it tells you what it does. Okay, so now what we're going to do, we're just going to mirror this part first. And we don't want to add it, we want to add a new one. Now we've got both these parts. They should be the same because everything's symmetric, but we're going to need 2 of them because now what we're going to do is we're going to use a Boolean subtract to get make the holes in the TPU. So when we subtract, we do want to keep the tools. That's our tool, that's a tool. Our target is this one. We're not going to do an offset because we want it to be a pretty tight fit. Go select, and then now if we hide that, you can kind of see we have this little tapered set of matching holes. Now, like I said, because this plate is going to stiffen this up quite a bit, I actually think we can kind of, get rid of a lot of that material. We kind of need it here, but I almost wonder, we could do something kind of interesting. We could kind of taper that out, so rather than having it be flat. So let's kind of do just going to create a plane. I don't like creating planes, but I do it when I have to. So basically created a plane that just kind of bisects that, and we're going to do a sketch on it. And we're going to kind of add a tapering effect to this. I'm going to switch back to the translucent view just so I can kind of see the relevant geometry. So we've got this ball end link pocket that the ball end link snaps into. We need material around that. So I'm just going to kind of use that as some reference geometry. I'm just going to kind of roughly sketch out some lines, add some references, kind of see what I almost wonder if we just leave it thick out here. Turn that up. The other nice thing, if we, like, so that's too thin. Do like to do things that print in the Z height in multiples of 0.2 millimeters, just so it kind of matches with the layers. That might be too thin. And we need to do that on both sides. Let's just see what that ends up looking like. We'll move through all. We're going to do it the other way as well, because our plane is in the middle, so we have to cut that way and that way. Oh. Interesting. We didn't quite catch a all of it there. So that looks really cool, I think. So let's hide this plane. That's why I don't like planes. They always get in the way. Okay, I'm trying to think what else. So we're going to print a couple of these things here soon. Just trying to think if there's anything else I need to add. I think that looks pretty good. I also think, let's go in here. We're going to make the assembly so that we can articulate it. And that means, remember yesterday we split the flat pattern up and we kind of moved everything sort of into position, but then we added this extrusion to kind of connect everything so we could make it one. We're actually going to suppress that extrusion, which is going to give us all of our components again. And we're going to kind of rename these. So this one, we'll call this one driver's side upright. I'll call this one passenger side upright. Driver side upper A-arm. Passenger side upper A-arm. And the lower A-arms. Cool. Now we've got names for everything. We're going to go into our assembly. And because we originally imported this, I think, as one component, everything's probably going to be broken, but we'll just bring them back in. But now, because these are all separate pieces, we can add sort of pivoting relationships to these, and we should be able to make that articulate. So yeah, everything's broken. But let's just, we're just going to start over here. Let's show all. I'm just going to fasten this piece. Cool. Now for now, I'm just going to hide everything else. We're going to insert. All these pieces. So now, as you can see, like they're all kind of separate from one another. Here's what we're going to do. So we're going to add, instead of a fasten relationship, we're going to add probably a revolute mate. We're going to start with the uprights, do it by the center there. So now let's mate this with a fasten real quick so it doesn't move around and we can test everything. So you can kind of see that has a pivoting mate now, and we're going to do the same thing, revolute, and we're going to do that between here and let's just get all these in. Okay, and now we should, I don't really have a good line, but technically we do kind of want these to, although you know what, I missed something. We're going to have to split this as well, but yeah, let's just do that now. Almost done. Split this component, and we're going to split it with this face probably. And then we're going to do another split. We're going to split this component, and we're going to split it with this face. And now we've got 3 components. We've got, instead of 1, we have these 3. Calm down, buddy. Hey, Potts. Potts. Come. Potts. Okay. Let's rename these 2. So call this one the lower center pivot. I'll call this one driver lower A-arm. And you guessed it, passenger lower A-arm. I'll go back into here, and we're missing some stuff. Let's just delete, we'll just redo them. Sometimes it's easier just to redo mates than to fix them. Need those components. Okay. So here, we're going to do the revolute again. This one might be interesting because we kind of need to tell it where to go. It should work right on the end. Let's do this side. Hey, buddy. Quiet. Excellent. Now we can refasten this. And kind of see we're starting to get some articulation. And so now we need to mate these to these. And a lot of times what I like to do is a ball mate. Because technically, especially these upper ones, where we're not really flexing on a sort of a parallel line, this really does act more like a spherical bearing. My dog just not like having people in the yard. So, ball mate, and a lot of times you can kind of select that mate connector and that mate connector. So it's not perfect because we're really getting flex in there, but it's really close. So let's just do another one. And you don't need to do it for all four because this is considered a rigid body since there's no moving relation or anything there. But now you can basically kind of flex the system. Let's insert, so part of why I wanted to do this, because I wanted to get a sense of the clearance. So let's insert our stiffening plates. And again, I think these are the same, so I can just copy them. And we can just fasten these. Just like that. And so now we can kind of get a sense of where we're going to have kind of some interference as that cycles. You can also kind of see what our geometry does. As you can see, we kind of Now if we wanted to get kind of a little more accurate, I could split this part right here as well and then do a ball link kind of in the middle, but for now this is good enough. It's the challenge of, you know, the ClickRigs. Most of the pivots are a compliant mechanism, meaning you're flexing the material, and so there's no, currently, as far as I know, at least definitely not an Onshape, but there's no good way to model that. So we approximate it with some tricks. And I'll be right back. 1 second. All right, sorry about that. We're back. Okay, where were we? Browser. Okay, so yep, we just kind of got this articulating. It's not a perfect setup, but it's a pretty good approximation, and it will let us do what we care about, which is figuring out kind of the clearance of this. You know, let's show it everything. Let's actually just get rid of these. Oh. I think I have a whole wheel assembly. Let's see if we can find it. that makes it a little easier. Essentially, this whole thing now is an assembly, sub-assembly, and so I don't have to remake everything. Let's copy this. That's not what I want to do. Let's copy that. And then let's fasten that, I believe. Flip that. Just going to fasten this kind of to the and I usually like to set these up so that at full bump, it actually lets the chassis hit the ground. One kind of easy way to do that visually is to highlight and just kind of drag these parts up until you just can't see it anymore. And that usually gets you close enough. And that would be extreme. Like, it doesn't actually have to be able to slam the chassis to the ground. And a lot of times that's actually not something that you would want, but nonetheless, that's kind of, it sets a boundary, and that's often a good thing to do kind of when you're starting out in a design, is sort of set somewhat extreme, I mean reasonable or tied to some actual function, but relatively extreme boundaries or limits, kind of. So like, what's the maximum amount of bump travel we could ever possibly want? And it's pretty much the chassis sitting on the ground at full bump. You not only do not want more than that, but you pretty much can't have more than that. So that's a very natural upper limit on the bump travel. You know, it might be that we want less, so we don't want to go crazy trying to optimize for that. But that's a good starting point. And so you can kind of see that's where we have interference. And so what we're going to need to do on this tapered chassis bit is probably come up and around. So our minimum distance, 0.936. You can kind of get a So we're just going to kind of eyeball that. We could edit this in context. For something kind of this simple, I don't totally think that's necessary, and no shade to Onshape, but sometimes I think the editing in context stuff, it can be really helpful in certain applications, but sometimes it just makes it more complex than it needs to be. So I think in this case, we're going to just kind of see what kind of clearance we can get and go from there. Okay. So let's jump over into this. Actually, you know what, the TPU bit takes a little bit longer to print, so let's get that printing before we jump into the modifying the chassis. So let's just kind of, I really do like that taper. I kind of want to do it here, but I also don't want to add a stiffening plate. So let's get both of these parts printing, I think. We'll just export the whole thing as a group, make it easy on ourselves. I don't bother naming things kind of in the prototyping phase. I just sort of save them to a junk folder essentially, and that makes it easier to, you just basically take the top one, and then because we brought these in as a group, we're basically just going to right click on it, go split to objects, done, and then I usually just hit the auto orient and that lets it, breaks everything kind of out. These two are going to be the PLA Pro material. So right now, we're just going to work on this one. Material. What did I change? Okay, I just made it a little denser, so we should be able to slice that. Give it a quick check. Let me make sure my support's off because I don't need it for anything here, but sometimes if it's on, it'll fill all these little holes in, and they're a pain to pluck out. Oh, it looks... generally looks pretty good. Let's get that printing. Should be 0C. All these are off. Says it's sent. Alright, now let's get working on these. So select both of those, change the filament. Going to change the process. reset that to the defaults. That looks pretty good. I'm going to send that to 0 beat. And we did, I don't run flow calibration every time. I usually do it whenever, definitely whenever I've changed a spool out. And then also just occasionally kind of throughout the use of the spool. I don't know. I could be all in my head, but I feel like that does tend to change kind of as the force required to unspool the spool changes, as the diameter of the spool changes as you use it. So I just ran it occasionally, but we ran it yesterday, so shouldn't need to do it. Same with bed leveling. Sometimes I do it, sometimes I don't. It just depends. But let's send that. Get those printing. Cool. Now let's jump back into the CAD and start working on the clearance for the tapered chassis. I'm going to go into this sketch. And essentially what we need to do is we need to come back up. So let's go translucent just to kind of, again, see what we're working with on the inside. So, this pocket tapers out. That's really just so this internal pocket can print with this side down without support. So it doesn't matter if this results in a hole on the top, because the snap dot actually only comes to a little bit below there. I'm just going to kind of let's do it on the dimensioned side. Let's jump back into this real quick. Probably like 1.5 millimeters clearance there, and then I guess that's almost parallel. So one thing we can do, let's just draw kind of ourselves a little reference line. We're gonna make it parallel. Was that B? Yeah, new keyboard shortcut unlocked. And we're just going to give this a distance. This is just kind of for reference. So like at 1, that's basically the height of our stiffening plate. And so we can kind of see that if we bring that all the way out, we're going to interfere here, and we can't do that. But that lets us kind of so I think we're going to need an extra node in this here. We're going to kind of have to do something like that. So we're going to want, can probably go straight up and down here. So let's call this vertical V. So we're going to be close, I think. Let's just see what that kind of gets us. Alright, something weird is going on because these holes are not the same. So our sketch did not. That's what it is. That might print kind of funny, but let's just, for now, let's jump back in and kind of see what that. So that gets us pretty dang close, though. Got a little bit of interference here. So if we move that, and what we can do is we can kind of select these and do an interference check. So we get a little bit right there. So I think what we need is a little bit of clearance down here. So kind of let's interference check this. So you can kind of see where we're hitting. So no interference. And just for, I mean, that's, let's say we want just a smidge tire there. So we can actually bring that down a little bit more. I'm kind of curious what the So I'm kind of wondering what would happen if we chamfer that. Can we? Definitely makes the part look all swoopy. Let's just fix this real quick. And then we fillet these. I think that part looks pretty cool. And so the only thing I don't like is this is going to create kind of a sharp thin edge, and I think that's going to print kind of yucky. So what I want to do, I want to create like so this is going to print sort of upright like this. I want to create a little bit of like a boss. So let's just try something here. Let's do 2 line thicknesses. So let's do curious if that provides clearance issues. Does a little bit. We're going to try it and see. I think a little bit of reinforcement there. I'm not sure that just one layer will be enough, but we'll try it and see how we like it. Let's add it to this side. Okay, I think that's It's a pretty neat looking part. So we've got our two stiffening plates. And those will essentially kind of go in there. The TPU part, the A-arms, have a little bit more to go. So let's see, let's export this and get this printing. Change the filament. Auto. We're all set there. Slice it. So I guess we'll see how that, although there's something weird going on there, isn't there? If we switch to classic, same deal. Somewhere there is a detect thin walls, maybe. Alright, we're just going to print it, see what happens. Won't take that long. Hopefully that lawnmower is not too loud. Okay. Alright, so we've added a stiffener plate, we've got an articulating model. We've cleaned up and provided some more clearance for this tapered chassis component. Kind of slimmed these up a little bit. think the next thing I'd like to do, we're going to need, instead of using the individual link pins, I think I want to do a, kind of for more strength and because I think it'll look cool, a single link pin that kind of ties the two together on one side. You know, on this one, especially with the reinforced front end kit, we've got a double link pin, but it ties it across sideways. I think I want to do the same thing, but tie it across that way. I guess technically this is a triple, but if we wanted to get so we could reuse the triple there. I kind of like the idea of doing a swoopy one, and then you get access to all of these snap dots for the hood and the whatever other components we want there. So let's actually go into the we'll use the component generator, and that's going to be a cap essentially. So we're going to copy that to the clipboard. I'll come in here. We're going to paste it in. Let's rename this upper A-arm link pin. We can go into the connector layout, and I'm just going to make a new one. And so this basically spans 5 of the grid locations, and so 5 apart. And we're going to build it off the center. This is where we're going to get a little weird. I think we want a or do we want to do something like at this point we can turn off the layout pattern. I'm just going in and so because this is a link pin, we're actually going to make the snaps a little bit taller. And we're going to get, this is how we're going to do it. So 3 and a 4. So we're basically going to add a pedestal, and we're going to select these, we're going to extrude those, and those we're going to go 3, we're going to draft, just like that. Add the peel flange. Basically what this does is it helps you get the part off. Sorry, that is loud. Might actually mute the mic for a little bit while that lawnmower is close to the window. Alright, so the lawnmower is still out there. Hopefully it's not too loud, but it's not right next to the window. And so I've got these components printing. We got the revised tapered chassis printed and some snap dots in it. We've got the stiffening plates. How much time do we have left on the A-arm assembly? 26 minutes. So in about half an hour, we should be able to test kind of all of these new, put together all these new components. So getting it refined. I'm really, that's been something I've kind of been wanting to do for a little while, is try out some stiffening plates on an A-arm front end. So excited to see how that's going to work. We've got our approximation of an articulating model. And I kind of like where these dual longitudinal link pin things are going. I might kind of tweak them a little bit, but we'll get farther along in the design and maybe make some tweaks. But I think the concept is sound. I generally like kind of how that comes into the corner. Yeah, I think you can kind of see, there's enough flex that you can tow these intentionally, and it might be nice to control some of that, because sometimes you come into a bump heavy and you're gonna get some flex there. And it's kind of interesting if you watch like slow motion videos of like a real trophy truck hitting something pretty hard. It's sort of incredible how much flex just in the components that you see. So even steel and definitely aluminum can definitely it moves around a lot more than you would think once you start applying a lot of high loads to it. We've got a couple more hours here today, so we're going to get quite a bit done, I think. I'm going to take a quick break and I'll be right back. All right, we are back. Okay, let's see, where are we at? link pins are about done. And I guess while this cools, let's I can kind of show you one of the things I like to do. I don't know if you noticed before, but it's just kind of hard to see in this light. There it is. On the top layer, I will usually essentially add like a 1 or 2 layer deep perimeter wall, just to kind of break up the large flat surfaces, because with the 3D printing, it's one of the sort of like extrusion in that way. If you're worried about surface finish, large flat areas, especially on the top layer, obviously the bottom layer is nice because it picks up the texture off the build plate, but the top layers, you're always going to see a little bit of the sort of the back and forth. It's not going to be perfectly smooth, although if you dramatically slow down your top layer printing, the surface quality or surface finish usually becomes quite good. I think I want to say even like 10 millimeters or 10 to 20 millimeters per second, I think, with this PLA Pro makes it quite smooth. And so that isn't always an option, but I've also always kind of liked you can kind of see it there, that kind of slightly inset pocketing. I think it just makes it look a little bit more complex, a little bit more interesting. So let's just kind of we don't have the TPU parts yet to snap in, but essentially that will go kind of like that. Alright, got a bunch of, let's kind of knoll these out a little bit just for fun. Okay, so I know we had talked about doing the toe control. I think I'm going to leave that maybe for the next iteration. Or that might be something that the Mayday character comes up with. I think that's sort of innovative, and a lot of what we're going to see kind of between the Mayday rigs and the Thorn Buckingham rigs. The Mayday rigs are going to kind of innovate kind of a lot of new concepts, but in a way that uses a lot more standardized components, is maybe a little bit more difficult to build and requires a little bit more attention to maintenance and prep as you play with them. But the Thorn Buckingham rigs are going to kind of like take a lot of those good ideas and then turn them into a more refined set of components that maybe hold up a little bit more consistently and are a little bit more elegant in nature, but also have a lot more kind of one-off or bespoke components to them. So I think that's kind of what we're going to see with the storyline of these cars as they develop. Mayday is always sort of pushing the boundaries and builds kind of like big beasts of vehicles that are super innovative and work really well, but aren't maybe always the most refined. And then Thorn is going to come in with all of his money and basically copy what she's doing in a way that is always incredibly well done. So we will save the toe control for the next May Day rig, maybe the MDRD02, or I'm kind of planning on doing, in the world of Harley Dome, both May Day and Thorne Buckingham, they compete. They're part of the racer crew, and we'll get into that more as we go. But essentially, they're the people who are trying to go the fastest on the gravity loops, and originally because they were trying to find a way out of the dome, and basically trying to set a fast enough speed on the alleged exit loop, which lets them kind of escape the dome, or at least let one person, the day the dome fell, was able to escape, but nobody has been able to basically go fast enough on the exit loop to escape the dome. So the racer crew, their whole shtick is they're trying to basically go as fast as possible so that they can attain a fast enough speed on the exit loop route to escape the dome. So they're basically all about speed, but they basically also have two kind of styles of vehicle, kind of more of a long course desert style, so something more like a trophy truck, and that is the RD. So the R stands for the racer crew, and the D stands for their desert vehicles. And so, like this is the MD RD01, so May Day, it's because it's May Day's car. She's part of the racer crew, and this is her desert car, and this is the first iteration of it. So this is version 01. But the racers also compete against one another kind of in more of a short course kind of stadium, and that's primarily just for the benefit of the crowd, because maybe I'll get into this a little bit now. So the currency in Harley Dome is essentially VHS tape. And so the day the dome fell, the town had just installed a giant Jumbotron screen, like from a stadium, in their town square. And it was for this big rally racing event that was about to take place when the dome fell and isolated them all and cut them off from, I guess, the rest of the universe, essentially. And so the town has this Jumbotron screen. And remember, this all occurred in 1989, and so everything was kind of, videotape. In this case, it was VHS. And so because sort of the way to gain status in the town of Harley Dome is essentially to either be a really fast racer. It's all kind of like off-road and sort of truck-based culture. And so the way to gain credibility is to either be really fast or to pull off like crazy stunts. And that would be the freestyler crew. And they sort of have a rivalry with the racers for obvious reasons. But the currency is essentially VHS tape, and obviously there's a limited supply, and you can only record over it so many times before the quality kind of goes to crap. And so basically the faster you are, or the more wild stunts that you pull off, the more you kind of get awarded VHS tape to record your shenanigans, which then every night in the town square, that's sort of like the social event. So everybody kind of gathers in the town square and watches videos from the day's racing and freestyling. And so if you're really good, you get more VHS tape. And that tape can be traded for other things like components or time on the fabricators at secret facility to make parts. And so that's really what everybody is kind of competing for. They just want more VHS tape. And in fact, one of like the biggest insults that can be thrown at you in the town of Harley Dome is that you've wasted tape. So if you do something that wastes tape, that's a pretty big insult. And so the racer crew, in part to kind of like ensure that they, have fans in the town, which helps them get more VHS tape. They also compete in kind of a closed course stadium style event that's close to town, so that there can be spectators and lots of people can watch it. And so both Thorn Buckingham and Mayday both have short course trucks as well, which are not in the store yet. I still have to design them. And those, the Mayday's truck would be the MDRS, and that'll be the 01. So the Mayday Racer Stadium version 1. And I forget why I started going down this rabbit hole, but I guess my point is there will be other trucks that these characters are going to get, and so they're going to kind of be chasing one another. Mayday will be innovating, and Thorn Buckingham will be coming along behind and stealing all the good ideas and making them nicer, and probably a little more durable as well. And so those trucks will be following. So I'm trying to figure out, what do we want to work on next. I think this is, as long as these components work out, we'll put them together here in a few minutes. I think the front end is pretty much done, which means we can probably move on to the rear suspension. So I usually like to get the chassis and the suspension and everything kind of finished up first, and then go in and start doing like the cab and the body work and stuff. I think one of the, so if we go back to the overhead here, one of the things that makes these vehicles work, and it can be a little bit different from like say a road racing car, where you're trying to get all of the mass as centered as possible, so that the vehicle, essentially is really good at transitions, like suddenly turning left or right. With an off-road truck, that still matters, but you've got sort of a compromise that you have to make, because off-road, one of the biggest elements that allows you to go fast is that the suspension has to work well. And in order for it to do that, unless you can make kind of the unsprung weight like incredibly light, which there are limitations there, you get a lot of benefit by, instead of having all the mass centered, having it kind of outboard, so that it has the effect of stabilizing the chassis and forcing the suspension to move. And that's a super simplified way to put it, but it's essentially what's going on. And so that's why you see, all these desert race trucks, they're hanging a whole bunch of weight off the back end, and they're doing that in order to get this thing to work, because the weight hanging out back here sort of resists movement. So instead of, when it hits a bump, pitching the whole truck like that, this wants to stay still because it has mass, and forcing that spring and damper to absorb that energy rather than accelerating the whole truck. And so because of that, you want sort of weight at the hanging out the rear end, and Thorn sort of wants his vehicle to be a little bit shorter, so it's a little bit more maneuverable to match his driving style. But to keep the suspension working as well, he's going to have slightly shorter rear links. But I think one of the things he's not beyond trying to add some innovation. He's not just going to copy, and the people he hires to design his trucks in the world, aren't dumb at all. And so I think he's going to try to get more weight than Mayday has sort of behind the rear axle. We might end up doing a double spare tire. I also think we can kind of get it a little bit lower, so when this thing's bottomed out, we can actually, this tire doesn't need to be quite so high. So having weight low is still very much a good thing, even though we're hanging it out back. We want it as low as possible. And so by kind of shortening up the wheelbase a little bit, we can probably get more weight farther behind the rear axle without the whole vehicle becoming too long. So as we move into the rear suspension design, I think that's kind of something we're going to try to sort of optimize for, is getting a fair bit of weight out back so that that rear forelink works really well without making the whole truck way too long. Let's see. Our TPU parts are done. So let's disassemble this setup. Build out with these new components. I guess we're not reusing any of those, so let's see. So how do these fit? Let's did we get it right? So this is the stiffening plate for the flexible front A-arm assembly. Snaps feel pretty good. Quite a bit stiffer, but will it be enough? Pop these ball links in. Put our new longitudinal double link pins on. And this just gets folded around. Look at that. These are a lot harder to put on now because of that flange, but I think they will save people a lot of it could be an easier way to do this. Could actually put these on first. Looks kind of goofy, but once you fold it all together, it makes sense. Yeah, there's plenty of clearance. We could probably make those plates a little thicker too if we wanted to. I might actually try that. Because in looking at it here, I think there's clearance for it. So let's just do that real quick. Made it 1. Could do 2. We'll try to. Doesn't take long to print. We might end up somewhere around 1.6, but let's see, is there anything else we want to change about that? I don't think so. Generally, when I'm prototyping, whenever I change a part, I just kind of delete it out of here, but then I let all the parts that have stayed the same in CAD since they've been printed just kind of hang out in the space, and that way, kind of, when I'm nearing the end, I sort of already have all the parts that I think are good in the slicer, and then I can print them all out as a single kit and just kind of test all of the fit up in the assembly. So let's bring in the new. We're going to print 2 of these. scared me. Hey, buddy, no barking. Hey, Potts, Potts, Potts. Okay, so while those are printing, let's get started kind of on this rear end. Again, I think he's going to pretty much copy what Mayday has done with the triangulated live axle 4-link. But he wants the truck to be overall a little bit shorter. He's a little bit more of a controlled driver, and so kind of likes, nope. Potts. 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 Okay, so let's go back to this truck layout and let's show all the parts. Because we had originally, wrong one. Kind of done a rough dimensional layout. I'm just going to hide some of these. So that's kind of roughly what I think the wheelbase is. So a little bit shorter than the Mayday. I'm trying to think. And I think he wants, so on the, if we go to the overhead here, the Mayday axle is quite a bit wider than the front track. The rear track is wider. Thorn kind of doesn't like that, so we are going to make it essentially match the front. And so you can kind of see we are going to have to do a slightly narrower axle. And the other change, I think, and I think we'll make a new axle, even though I might have one from one of the other kits that is the right width. Again, one of the primary design directives for the Thorn vehicle has been that things like wheels flying off during a hard hit or a crash, or components coming loose and needing to be prepped by kind of retightening everything, is not really Thorn's cup of tea. And so in that spirit, these rear axles, in order to retain the bearing onto the axle, especially because the axles are rigid components and not flexible TPU components, you have to insert essentially a small TPU wedge. Let's see if I can show that. And that's that little orange piece there. Kind of fits in that groove. And when you assemble these, you have to kind of hold it on and kind of do your thumb and then kind of smash it on. And it can be a little bit finicky. And so, it's not terrible, but basically you have to do that every time a wheel comes on or off. It's a little bit more finicky initially, and even over time, keeping the wheels on the car just requires more effort. In a big crash, you're probably going to have to reinstall a wheel, which isn't terrible, but Thorn is super lazy and he doesn't want to touch the car at all once he's going and driving it. And so we're going to make this kit kind of respect, I guess, that desire. And so in that regard, I think we're going to have to rethink a little bit. This will be another area where there's probably a little bit of innovation, laziness-driven innovation, I guess you could call it. We're going to have to rethink the rear axle so that the bearing and wheel retention system is a little more robust and a little less finicky to assemble. And so we've already done that on the front with that little flare. These wheels should be very, very well retained. So we're going to have to figure that out on the rear. So maybe we do that first. So maybe we just start by redesigning the rear axle. And I don't have a ton of ideas there. I mean, kind of the only thought I had was maybe we kind of do a similar, basically we print this kind of part of the design that inserts into the bearing and has this little retention lip. Oh, we have a failed print. Hold on. Probably because I've been touching the build plate. I usually wash a bunch of them in the dishwasher and just kind of use a new one almost every time. But let's kind of cheat here and move it to a hopefully clean spot on the build plate. Okay, so like I was saying, I think we could probably do something where we print this component out of TPU and then part of the axle, it's got some kind of hollow receptacle, and then the axle sort of plugs into that and snaps in. Couple of challenges with that. The axle prints, it's like a partial circle so that we can print half of it flat on the print bed. So the component that sort of plugs in will have to be raised. I'm trying to think how else you could do that. Might not be terrible. Let's just try some stuff. In fact, I wonder, we've already got, this is a separate component now, so we can probably just derive that in. That's handy. So let's do that. This one. That's right. We've hit that twice now. I'm trying to get too tricky. Cyclical reference destroys the very nature of space-time. Let's see. Physics people out there, don't mind me. I'm not making any sense, but it's okay because this is not a it's not actually a physics live stream. Okay. So how do we get that in? That is the part we want. Does that mean I have to save it as a step file and then re-import it? In some ways that that might get the people on the internet yelling at me. That happened to Vice Chief. So I think that means that's what I'm going to do. So let's do that. We're just going to export this component. We're going to call it hex axle hub. It's not really the hub, but we'll distinguish it from being the whole axle. And just throw that in there. And now we are just going to import it. Let's import it into here. Dirty, but now we should have it in our studio. We should be able to derive it in. Wherever it is. There it is. Now let's mate it. I think, was it hold command? No, control. So basically I'm trying to get to that middle thing, but without selecting this face. So I want the middle center point from this. If I hold control, no. Shift? Shift. Okay, so that's the key. Everybody probably knows this, but I don't, so I didn't. So it's always annoying because Onshape essentially gives you all these kind of like pre-made sort of mate connector points. And what I want is the middle of this face because I'm going to mate it to a round thing. So sometimes by just moving a little bit like there, it lets you get it. But if you move elsewhere, it won't. So if you go to the face you want, you hold Shift, maybe I'm just making that up, but I think it kind of holds the initial reference. So anyway, we have that mate connector. Now we want this one. Let's flip it. Look at that. Pretty cool. Now let's just move it again, but this time we're going to copy this part. I'm going to do mate connector. And I'm just right click. I'm using isolate here so that I can kind of quickly. Yeah, Shift does. It does do that. Then you just close it. Now we don't have to hide and unhide a bunch of things. Flip that. Bam. Okay, so now we essentially have our very robust hex connectors that we know work. Let's do a couple things. And isolate also, pretty sure lets you multi-select and isolate. And we're just going to kind of be a little dirty here. I don't like square edges. I could fillet it, but I think this is probably cleaner, and then I don't have to. Can we do all of them? Does that work? Will it know that I want to go opposite directions? We'll find out. I'm just going to select those faces and do an extrude. We're going to go remove. We're going to go through all. And we're going to merge scope these two pieces. Look at that. But that's a little bit what I was worried about. I kind of didn't want to. It's kind of interesting. I really wanted that to look like one surface. Just keep the geometry a little cleaner. Let's just try something. Let me suppress that real quick, and we'll just try it with a fillet, see what it likes. So yeah, because we brought this in as a step, dirty. It's not actually treating that as a radius, so we're just gonna call that good. If it's a problem, we'll just remodel it from scratch and clean it up. If it's not a problem, then we're not going to worry about it, because that just takes time. And if something works, it works. Okay, so now let's just do a sketch. Doesn't seem to let you isolate inside of a sketch though, so quiet, buddy. Quiet. Here, Potts. Good girl. Good girl. Fight. My dog speaks German. I do not, so if my pronunciation of those words are offending any German speakers out there, I apologize. Just going to make sure I've got a reference point based off that circle. Now, because all the vehicles, the ClickRigs vehicles are gravity powered, and because they exist in the world of Harley Dome, where the vehicles are also gravity powered by the strange sort of infinite gravity loops that lead from out of town downhill one direction, and you roll back into town 180 degrees from the opposite direction. Everything pretty much, all of these racers and freestylers and even the flying pancake utility truck are all gravity powered, which means technically these axles don't have any gears. They're not connected to a drive shaft, so there's no power transmission going on. They're almost entirely just locating and there for suspension purposes. So this doesn't really need to be round. I kind of like the round shape though. Let's jump into here real quick. And here's, you can kind of see the the little TPU wedge that has to be put into the groove of the axle where you put the bearing on. So that's the part we're going to eliminate. So I just wanted to see what, this is kind of an 8mm diameter. And let's see, let's go back. What is our, basically have a, we'll call that 5mm flat on the axle, just to allow it to print. Also gives it a little bit more ground clearance underneath. So we're going to draw a line. We're going to make sure it's horizontal. And we're going to give it a dimension. We'll call that 5. Trim that up. Six isn't bad either. Let's start there. I'm going to extrude that. Let's do a new component. We're going to go up to face. We're going to select that face. Okay, so that's kind of our base axle, and now we need something protruding into here. And honestly, yeah, actually that won't be a problem. That's what I kind of want to do though. Let's hide everything else. Let's work on this. Our parts are done printing, but let's we'll just let that cool for a little bit. Essentially, it's just a thicker top plate, stiffening plate for the lower A-arms. Do a new sketch. Just kind of want to get a reference. So Q for construction and U for use. So I'll kind of project this because we have to stay, we need enough wall, so we're going to have to stay within that. I'm going to hide these. Use that too, because ideally that just gets extended. So there are a number of ways. This technically doesn't have to be round. I guess it would be a little stiffer if it was, but you know, so we could just have like a let's actually show that part again. So you just kind of have a rib. So let's maybe start, let's do some offsetting. And this is just going to give us a reference for the wall thickness. It'd be nice to have 3 walls on that. So we could just kind of match that. Let's extend those down. Let's show that part. We lost the reference there. So that should print pretty well. Nobody. No. So here's what we're going to do. We're going to extrude it. We're going to add it to the axle. And extrude it the other way. And we're going to go up to a face. We're going to go up to this face. And that actually could be interesting. We could kind of poke it all the way through. Give a little bit of a reveal there. That might be kind of nice. Hey, no, pause. I know you're stressed. That's okay. Pause. Showing your rope. She does not like the lawnmowers. Pause. Pause. Pipe. Okay. So now what we need, essentially I'm trying to figure out a way to retain that. So we kind of need some sort of interference feature. We could add that out here at the end. That could be interesting. So maybe yeah, so let's actually go back here. Let's just get you a second in position. We're also going to do up to face. I'm going to do a Boolean, subtract. That's the tool. These are the targets. So now we've removed that. So now one thing we could do, we could add a little flange here. I wish kind of 3 layers. Probably doesn't need to be a bunch. I mean, I wonder if we can do like just a little bit there. Will this let me do both? Yes, but it goes the wrong way. And then this needs to be flat. So just kind of, we'll move this face. Let's see, can we just move this Boolean down? Essentially to get that that flange in there. Yep. That would probably, curious how hard it would be to insert. I guess we can adjust that. Offset there. 0.3, how much is 0.3? Let's I mean, that's not much, so kind of feel like 0.5 might be better. Mm-mm. I'll try it, see what happens. However, let's see, I guess it really doesn't need, because it's printing from here. So we actually, at first I was thinking it'd print upright and it would need a chamfer there, so we don't have to have a support, but we actually don't. So I actually think we're going to make this one really thick. Maybe. And then we're going to add, I think, a bit of a chamfer here. Just to help it kind of insert into the TPU. So we might have to play with, again, how much offset there is, but I think that might work. It should retain the bearing very well, so as long as this part can be inserted into that part fairly easily, and as long as those two are retained together, this concept might work. Okay, so now this whole thing is going to be on the grid because we're gonna go in now and we're gonna put kind of suspension link connector points. And so I like to build those on the grid so that this axle could be used with something else if you wanted to. So we're just going to pick up kind of the furthest outboard and the center point. Trying to think if there's any reason we might want more than that, but I don't think so on this one. And right now we're just building the axle, so we'll build the link connection points, and then we'll pick up kind of where the other end of the link will go. And so these should be the right diameter. We can just kind of extrude these. First one's going to be up to the face, which is going to be here. And then the second direction will be, can we do it this way? because basically I need this to be 10 millimeters tall so it matches the chassis spacing. But if we go up to face, but then we go offset 10. Nope, doesn't really work, does it? I'll start there. Problem is I don't know what the distance from there is, but you know what we can do? Show the sketch. See, that's unfortunate. This is an interesting little conundrum. I mean, obviously I can go in and figure out the exact numbers, but that's not fun. So the problem is this plane we're basing it off of. You know what? I know how to solve this. Let's just do this the easy way. Let's go back into the sketch, and instead of using the top plane, let's just use this flat. And now we don't need two directions anyway. I'm just going to do this blind. I'm going to go 10. Bam, there it is. Now we've got 10 there, and we only have one extrude. So one less thing in the tree, and no pasting 5 numbers with 5 significant digits. Quiet, buddy. Quiet. Fox. Good girl. Okay, so now what we need to do is make the snap dot pockets, because these get snap dots. And so for that, we'll borrow from here. As you recall, these are our plugs, and they're slightly different just because basically this is the build plate side, and this is the top, and the tolerance has changed just slightly. Enough to just have slight different geometries in the two. And so we basically need to bring in 2 of those. And then we're gonna do the same thing. Do it one more time. We're selecting copy the parts. Actually, you know what? I think I want to flip that. Or do I? Let me double check here. I might have gotten the tapered chassis wrong. I think I did. Oops. Because technically this one prints that way, and that is the top. But that's okay. We can fix that here in a little bit, but for now, let's just basically the red, or the gray one goes on the side that prints on the build plate, which makes sense because those are called the bottom. So in this case, actually, it's correct, I believe, right? Now I'm getting confused. Red goes on the top. Red goes on the top. So we're actually good here. We are just not good here. But we'll fix that later. Now we're going to use a Boolean, subtract. We don't need to keep the tools. Target is the axle. Now we've got correct and printable snap-dot geometry. Okay, so I think let's go ahead and print these parts out just to sort of verify that this whole system works. mower is close again. Got our thicker A-arm plates. Again, we brought in a group, so we'll split that to objects. See how that does. Alright, got about 15 minutes. Might be just in time to test these things out. Let's see, what's the about 18 minutes on the axle, so we might stick around just to see how those work, or maybe we'll start with that tomorrow. I'll be streaming again and continuing the design process of the TBRD01 ClickRigs trophy truck kit, which will be the second trophy truck kit in our catalog at ClickRigs.com. Let's see. Now let's jump back. Let's actually check out and try out, install these thicker A-arm plates. Basically made them twice as thick, a little bit more stiffness. Yeah, I still think there's plenty of clearance, so we're going to go with the stiffer one. overall, I think that's pretty good. Put this in the pile of discarded parts along the way. And so right now we are printing kind of this new axle design, which sort of uses a similar retention system as we use up front. We got this TPU flexible component with a little bit of a ridge that slides over this rigid part of the axle and hopefully fits and goes in and retains, and it should work better than this system that we've been using. Hopefully it works better, and hopefully it's also easier to put together. That's the idea. Vehicle development, racing, it's all about continuous improvement. You keep making things better and better. And so that's, I think, part of the fun of the ClickRigs system too, is that we'll have all these kits that kind of showcase sort of the iterations and the development and the progression. So hopefully this works. I think this is a good approach. Find out. So that's kind of our rough geometry there. You know, I think let's bring up the grid layout. So we'll start figuring out where the trailing arms are going to go. They're obviously going to go from that point probably to that point. That would be my guess. We could come out a little bit wider. I mean, on the Mayday kit, we come out, yeah, two positions outboard of the domino chassis, and actually one forward. Which would actually be like here. Kind of curious what. That's a 70 millimeter trailing arm length. What are these? So that's a little over 80 millimeters. So the 70 is probably not bad. You see what's going on here, though. going to make our lives easier. So when designing these, I kind of like to design them in the sort of flat plane, but because of the way we did this axle, it's not center lined. So what we're going to do is we're going to move this whole bit down. Let's see, hold on 1 second. Be right back. All right, we are back. Let's see. So we are currently working on the rear link lengths, and I think we're going to go for a 70. Yeah. Let's just kind of start drawing those. ourselves a center line. It's interesting. Is that the right one? Yeah, it is. So it's interesting. That link, unlike this one where they kind of flare out a little bit, it looks like the trailing arms for Thorne Buckingham's truck are going to come straight back, which will be actually going to be kind of cool. Give it a little bit different of an aesthetic. And we'll get the side-to-side location from the triangulated upper link anyway. Alright, looks like our axle components are done, so let's check those out. Moment of truth. Tight. But once you get it started, it is not bad. So there's definitely, I'm going to have to make sure that that's there's a side. I think that's very solidly retained. Steal these real quick. Very tight. But definitely not going anywhere. So I think that does an excellent job of retaining the bearings, which will in turn do a good job of retaining the wheels. You know, and through use, like any part, they do kind of loosen up a tiny amount, so it's probably a good starting point. Excellent. So now we've got, let's make sure let's throw some snap dots in there. Put this one in crooked. Excellent. So I think that is a very solid design. And so that's about where that will go. So now let's design some links. And it's time. We've been here for 4 hours today designing some parts. We've made some excellent progress. We've got some stiffener plates on the front arms. We've got some longitudinal dual pin link pins for the upper arms. What else have we done? We got a brand new axle with a brand new axle retention system, which I think is going to be amazing and will probably get copied into a lot of the other future rigs as well, not just Thorne Buckingham's rig. And so, yeah, I think that's it for today. So thanks for watching. We'll be back tomorrow. Like I said, Monday through Friday, including tomorrow, 8 to noon Pacific time. I'm designing a ClickRigs trophy truck. So follow along. Thanks. Bye.